Hey guys, working with our multiplication again, and we are in lesson 7, so make sure you're in lesson 7, page 127. Lesson 7, page 127. Okay, now, the only thing that is different a little bit today is now that we are multiplying 3 factors instead of just 2, so 3 numbers instead of just 2. So we have 2 and 3 inside the parentheses. So they're just grouped together. We always do what's in parentheses first. So we would look inside the parenthesis. We have 2 times 3 in the parenthesis. So what's going to come out of that parenthesis? A 6. And then we still have times 10. Now, we know from powers of 10 or multiples of 10, we can do quick math. So we multiply the whole number parts that we see. 6 times 1 is 6. And then we're working with 1 multiple of 10. On the second one, we're still multiplying 3 numbers, 3 factors. We have 1 set inside the parenthesis, and we always do that set first. So we have 2 times 40. Well, we know with quick math, when we're dealing with multiples of 10, we can multiply the whole number parts that we see. 2 times 4 is 8, and we're working with 1 power of 10. So what's going to come out of that parenthesis? 2 times 40, 80 is going to come out of that parenthesis. And then we're still going to have times 10. So then we can use quick math again. We have 80 times 10. So we're still working with multiples of 10. So we can multiply the whole number parts that we see. 1 times 8 is 8. And we're working with 2 multiples of 10. So our final answer would be 800. On the next one, the same concept, we're just working with higher multiples of 10. So inside the parenthesis, we have 2 times 200. So we would have 200 times 2. So we always put the big one on top. We can multiply the whole number parts that we see. 2 times 2 is 4. And we're working with 2 multiples of 0. So 400 is going to come out of that parenthesis, and we're still multiplying that times 10. Then again, we can do quick math because we're working with multiples of 10. We can multiply the whole number parts that we see. 1 times 4 is 4, and we're working with 1, 2, 3 multiples of 10. So our final answer is 4,000. Okay, now this one, we're still working with 1 power of 10, but inside our parenthesis, we have 2 numbers and none of them are 0, so that's not a power of 10 number, but we would still multiply what's inside the parenthesis first. So we would have 243 times 2. Now, we've worked earlier in the week with just using the standard algorithm, and remember, algorithm just means steps, so the standard steps that we would take to multiply. And we always start with our bottom number that's in the ones place, and we multiply it times each thing up top. So we have 2 times 3 is 6. 2 times 4 is 8. 2 times 2 is 4. So coming out of the parenthesis, we would have 486. And we're still multiplying that times 10. So now we can do quick math. We have 486 times 10 we multiply the whole number parts that we see. 1 times 486. That is 486. And we were working with 1 multiple of 10. So our final answer coming out will be 4,860. Okay, now let's turn on over to page 128. It tells us to find the value of 286 times 4. And it says that Tyler used the standard algorithm to calculate. What does the 2 over the 8 represent? Okay, if he used the standard algorithm, and looking in the book, if we look at his work, here's Tyler's work. He used the standard algorithm or the standard steps. And it asks us, what does the 2 over the 8 represent? Well, I know that when I'm using the standard algorithm, I multiply what's in the ones place times each number on top. So if I multiply 4 times 6, I get 24. So the 2 that he carried up here, that's in blue, it represents the 20 associated with your first multiplication. Okay, so he carried the 2. You don't have to use a different colored marker. They just do that in your book just to kind of help you make sure that you keep up with what you're carrying. Don't try to do it in your head. Always write it down. Even I still write it down. I've been doing math for a long time. I just always write mine a little bit smaller than the numbers I'm working with so I can tell that it's been carried over. So then he does 4 times 8 is 32 plus the 2 that he carried would give him 34. So he puts the 4 in the ones place, or in the tens place, the tens place, and then carries the 3. So now he has 34. That's the 34 that he got when he multiplied and added his carryover. And then finally we multiply the 4 times 2, so we have 4 times 2 is 8. He carried over the 3, so 8 plus 3 is 11. So that's how he got his final answer, and these represent what we've carried over, what place value we've carried over from the previous multiplication fact. We already talked about that, okay? Now it says use Tyler's method to calculate 375 times 3. So remember, we always stack them on top of each other and always put, let me move that down a little because we're going to have to carry. Always put the largest number on top. So we have 375 times 3. And we start with what's in the ones place and multiply it times each number on top. So we have 3 times 5 is 15. So I would put my 5 here, carry my 1. And again, you don't have to do different colors. See how I just always make them smaller than my regular digits. Then we have 3 times 7 is 21 plus the 1 that we carried. So there we put our 1, and then we would carry our 2. So that gives us the 21 that we got on our last math fact. And then finally we multiply 3 times 3 is 9 plus the 2 that we carried over, and 9 plus 2 is 11. So if we use Tyler's method, the standard algorithm method, we get not that answer. I didn't add my carryover. We all make mistakes. I'm sorry. 375 times 3. 3 times 5 is 15. And we carry our 1. That's what I forgot to add back a minute ago. So don't do like me. I forgot. Make sure you write it down and remember. 3 times 7 is 21. Plus 1 is 22. So we have 22. So we carry over the 2. Then we have 3 times 3 is 9, plus 2 is 11. So 1,125. All right, on the next page. Step number 1 says multiply 216. Well, this is not wanting to cooperate today. 216 times 3 using the standard algorithm, and remember, algorithm just means steps. So we put our large number on top. We multiply 3 times 6 is 18, and we carry the 1. 3 times 1 is 3, plus the 1 that we carried is 4, and 3 times 2 is 6. So using the standard algorithm, 216 times 3 is 648. And then it says on step 2, it still has, we'll leave that there so we can compare. This time it says Lynn used the standard algorithm to calculate 216 times 43 instead of just 3. So if we look at Lynn's work, his first row here, that's the same that we got, because we had already done the work for 3 times 216. So that's where he gets his 648.